Hi there, Jim here. Today we're going to have a look at this Zoyi ZT-225 digital multimeter. It's hard to tell that that's the model number in here, but it is here on the back on the labeling. I got this meter, I ordered it with my own funds from AliExpress a little while ago. It seems to be becoming somewhat popular. It's a 25,000 count multimeter, and a lot of the meters that are made by Zoyi tend to be at the lower end of the scale, lower numbers of counts, lower accuracy and performance. This one seems to be getting a lot of good mention and a lot of building up a reputation. So I thought it'd be worth bringing it into the lab and giving it a try. Now, if you found this video to be helpful, please give it a thumbs up and subscribe to the channel. Questions and comments are always welcome. The feedback is appreciated, and it helps me figure out where to focus my activity. Now let's get into the box. The box is a little bit scrunched from the shipping. I will say there was no extra padding added to the shipping envelope. So there's a case and a user manual. User manual's all in English, which is interesting. It's 25 odd pages, so that might come in handy later on. And if we open this up, there is a set of probes. We'll see how they feel in a second. There's a temperature probe, so it's a little bit of a different temperature probe. Quite often you get these with just the bare thermocouple at the end, as opposed to this long metal rod. We'll get back to that. And then there's the meter itself, and a little bit of an interesting warning here. It says, stop testing voltage in current mode, tear off before use. So yeah, you're not supposed to do that. We'll see if there's anything special about that, whether there are any automated warnings or detections or things like that if we have the probes hooked up here and we switch into voltage mode. So we'll see. And then the dial turns fairly nicely, but did not come with any batteries, so we'll pull those out of the pile in a second. Now before we get into this, let's just have a look at the probes. So pretty standard PVC wiring. Got the sheaths here for one of those cat ratings. Okay, these sheaths are a little tricky to get off. There we go. So that comes off. Okay, I'm sure the red one will be the same. And I mean, they feel okay, but they're standard budget probes. Nothing too special there. The temperature probe. Okay, so we'll give this a try eventually, but the sensor is probably somewhere towards the tip of this probe. And I mean, that's okay. It's better than the typical kind of temperature probe where there's a very kind of thin wire that's just flopping around all over the place. So that's nice enough. And so that's everything in the package. We'll need to get some batteries in there. The battery compartment is just behind the stand, and the screw, I don't know if you can tell, it's a little bit of a tight fit, not too bad, but at first I was wondering how I was going to get the screwdriver in there. Okay, and that comes off and comes apart, I guess. I'll have to make sure to put that together properly. And One of the things that I always like to see, threaded brass ring in there for the screws, that's a good thing. And this meter takes AA batteries, which is also a nice thing in a sense. So let's get those batteries in. Slide those in. Pretty simple. And we'll put it back together. And like I said, that's a bit of an annoying design where the stand is hooked on by the battery cover. So you just have to be careful when putting that back together. Good. Let's peel off the protective plastic film. Okay. And let's turn it on to any random setting. Okay. Oh, it has a beep, but it's a nice and subtle beep. So it's not one of those loud, obtrusive, hello, welcome to the world beeps. One thing to notice is the unit does have a backlight and a light. It seems that the backlight and the light are controlled together. I couldn't find a way to activate the light, the backlight, without this forward light. So a bit of an oddity there. The backlight's pretty good. Okay, well, the next thing to do is going to be to start putting it through its paces. And I'm going to do it using the default probes that come with the unit. First, we're going to look at DC voltage. If you've seen some of my earlier videos, you may have noticed that I've switched to using some reference sources for my multimeter reviews rather than doing comparisons against other multimeters. And so that's what we're going to do for voltage. I haven't turned on the reference source yet, but I will. So that's 10 volts. That's a little low. 7.5 volts, fairly close to the reference. 5 volts, a little low again. And 2.5 volts, pretty close to the reference. Overall, pretty close to the reference, if a little low. Certainly nothing major to be concerned about. AC volts, and since I don't have a reference source for AC, I've brought the Bryman in for comparison. Turn the power on, and you can see that they're both pretty much reading the same thing. So I think that's really fantastic. Good job on the Zoyi, which also has the 2-line or the frequency readout at the top here. On the Bryman, of course, I've got to hit a button to get the frequency display. So now looking at resistance, and I'll put the actual reference values in the overlay text. I will call these out as I go through them. That's 10 ohms, 100 ohms, 1K, 10K, and 100K. So generally, pretty decent on the readings. It just seems to take a while to register. Now the same thing for capacitance. We've got a capacitance mode here on the meter, and so I'll read these out, and the values, the reference values, are in the overlay. So that's 100 picofarads, 1 nanofarad, 10 nanofarads, 100 nanofarads, 1,000 nanofarads, and 10 microfarads. Okay, so fairly reasonable on the capacitance. Now we're going to do continuity. Continuity is one of my favorites. And so now that's in continuity mode. And for continuity, I slap the probes together. So it's a little bit slow to react. But it could be the probes. So I'm going to switch over to a different set of probes and we'll see if that makes a difference. So now I've got a pair of gold tip probes for continuity. We can see that the quick taps are getting picked up pretty well. Maybe a really quick one gets missed every once in a while, but pretty good. And so the default set of probes maybe not the greatest for continuity testing. Now we're going to look at diode check, and I have a test box here. I'll just put us into diode check mode, and so let's go through and see what happens. So we can see that lights up that LED. So lights up all the LEDs pretty well, but there's no sound emitted on these two diodes or the short. And that's one of the things that I've been talking about quite a lot in my reviews. I really do prefer the meters that produce a beep or a solid signal in diode check because that makes it possible to do testing without having to look at the meter all the time. So many meters with that diode check mode will give us a little bit of a beep when we test the diode. They won't do that for the LEDs, but when we test these regular diodes, we'll get a little bit of a short beep, and in a short circuit condition, we'll get a solid beep like continuity. And so I do prefer to see that sort of behavior in multimeters. Now non-contact voltage, you can see that the meter is showing EF on the display. I test the non-contact voltage by taking this wire and waving it around the sensor. So this is the hot line here. And so when this part of the plug comes close to the sensor, we should be seeing some sort of reaction. So not much out here. You can see that as I get, the sensor is right at the top here where my finger is touching now. And so if I put the plug right at the sensor, I get 5 bars and a lot of beeping. But at about a centimeter out, I get the 2 bars, and a little further out, there's no sort of very little signal. So you've got to be reasonably close to the non-contact sensor. So workable, but not extremely sensitive since you've got to be right on top, and it might be difficult to get the sensor right to where you want to be. The unit can also do live wire detection by putting a test lead into the positive socket, and we have the plug, and let's try the ground connection here. Okay, nothing much there. The neutral connection, nothing much there. But the live connection, pretty solid, pretty clear. So good live wire detection. In order to test DC current, we need to insert the meter in series with the part of the circuit that we're going to be testing. So I have a very simple test circuit. It's a 5-volt supply and 150 ohm resistor. We can use Ohm's law if we're familiar with that, and we can compute out what the value of current should be. And if we do that with Ohm's law, we get about 33 milliamps. And there could be a little bit of extra resistance. Sometimes the breadboard acts up a little bit. Sometimes the probes add a little bit of extra resistance. But we're looking for something on the order of 33 milliamps. Now, if we switch the meter, we'll first go into the amp range. One of the interesting things to note is we've got a symbol that's lit up here in order to remind us that in order to measure whether it's amps or milliamps or microamps, we need to put the probes over here on the meter and not leave the probe over there. The probes go over here. And so we need to move this probe. So we're starting first with amps. So we're going to put the probe in over there. Let's just slide that up a little bit. And I will turn on the circuit so it's energized. Just connect these. And so in terms of amps, we're seeing about 31.78. That's milliamps. So that's pretty much what we would expect. Now, this meter also has a milliamp range. So let's shift over to the milliamp range. We'll put that into milliamp mode and plug in there. And once again, 31.96978 milliamps. So that's pretty close to 32. So that's pretty close to what I would expect. Most of the time when I do take these readings, there we go, 32. Most of the time I do get a reading of about 32 milliamps as opposed to the exact sort of Ohm's law formulation. Now looking at temperature, I've plugged the probe in, and because I've got a multi-line display, it's showing me Celsius here in the big display and the Fahrenheit equivalent at the top. And if I hold the rod in my hand, eventually the temperature does start to move up. And so it's a matter of knowing where the sensor exactly is, but I can usually get the temperature up to about 30 Celsius. Okay, so that's temperature. That's pretty good, although it seems to be a little bit sluggish to react. A couple of other features on the Zoyi, and these pretty much operate the way you would expect them to. There's a hold function, so I've now got it. It's currently in voltage mode, hooked up to my bench supply. If I press the hold button, hold lights up there, and it holds that reading. And although I'm changing the voltage on the bench supply, that doesn't change. When I release the hold, the voltage updates. There's a max min mode. I've got the fluke set up here so that it's tracking the actual voltage, whereas I'm going to put the Zoyi into max mode, for example. And so I'm going to turn the voltage up a little bit. You can see the max is responding to that and adjusts. Now that I turn the voltage down, as I turn the voltage down, the max is locked in, and so it doesn't change even though the voltage is changing. And similarly for min, there's a minimum voltage that it tracks, and the voltage can drop. Once the voltage drops below the min, a new min locks in, and if the voltage comes up, the minimum is locked in. So that's typical max min mode voltage operation. Quick little teardown of the unit. We can see here the non-contact voltage sensor. So nothing really sticks out into this area of the molding of the case. It's not really clear why they molded that plastic that way. This is a the DMM chip. So this is sort of a DMM on a single chip. And I'll put the part number up on the overlay. Here we've got the LCD driver, part number on the overlay. And this chip over here is a little EEPROM which stores the configuration calibration data for the DMM chip. You can see a couple of MOVs here. The fuses here are not very special, especially the 20 amp fuse. I'd be a little bit maybe concerned if the 20 amp fuse were to blow in a bad situation. It could sort of spread all over the inside of the meter because it's not one of those sort of like shatterproof designs. And aside from that, not much else, because since most of the operation of the meter is controlled by this chip, we really don't need a lot of other electronics. I mean, the other side of this is going to have the controls for the rotary switch, but that's about all. And then these are the contact points for the battery pack. So it opens up pretty well, and the self-tapping screws go directly into the plastic. So if you do open it up, take a little bit of care not to chew up the screw holes too much when you put those screws back in. So overall, a nice unit. 25,000 counts, which means extra digits here on the display, although not quite as precise as some higher end, more costly meters like the Bryman. A couple of things that I'll point out. The warning here for making sure that you've got the probes plugged into the right sockets when you're measuring amps is nice. This has a 20 amp upper limit on the amp measurement, which is unusual. Most meters top out at 10 amps, so that's a difference. And of course, I might wonder where exactly one would pick up a fuse if I were to blow a fuse, but that's a different matter. The probes are okay, although I will say that I had a heck of a time getting the probe tip cover off on the red one. Pretty much had to use some extra tools to get that off. It would not just come off using my hands. So that was different. The one thing that really was the sort of largest drawback with this unit was the lack of a beep for diode check mode. So when the diodes have that continuity at the sort of proper forward voltage drop, it didn't make any sounds. Measured the forward voltage drop reasonably fine, but no sound produced by the unit on that drop. All right, well, that's all there is. Thanks for watching. If you found this video to be helpful, please give it a thumbs up and subscribe to the channel. And until next time.